So today we're going to continue on talking about quadrilaterals, and today we're going to talk about the rhombus. So we're using the notes from yesterday that we filled in the chart for the parallelogram. We're just going to do the next column for rhombus. So remember from the other week when we talked about quadrilaterals, when we did the definition of rhombus, we said it was a parallelogram with 4 congruent sides. So because it is a parallelogram, the 5 properties that we talked about yesterday also apply to your rhombus. So your opposite sides will be parallel, your opposite sides will be congruent, your opposite angles are congruent, your diagonals bisect each other, and your consecutive angles are supplementary. So those 5 properties are not new. That's what we worked on yesterday. That's what we worked on before we had the snow and the virtual days. So those 5 are not new. What are new are the 3 down here at the bottom. A rhombus is a special type of parallelogram. It's a rhombus because all your sides are congruent. So that's going to be a new property that we use today. Another property that's new specifically to the rhombus is the diagonals bisect the angles. So we're going to check that box. And so remember, diagonals are the segments that run corner to corner through your shape. And bisects, we talked about that yesterday. Okay, I'm just going to circle it again. Bisect means cuts in half. So we already have that written up here in the top in red. So the diagonals bisect the angles. And then the last new property that we're going to look at today is this last one. Diagonals are perpendicular. Now, perpendicular is a new word. Well, it's not a new word, but it's a new word here. So remember, okay, if you have lines or segments that are perpendicular, they intersect and they make right angles. That's what perpendicular means. Okay, so the 3 new properties that we're going to look at today are these. All sides are congruent, your diagonals bisect the angles, and diagonals are perpendicular. So let's go over, keep this out so that you'll have it to refer to. And we're going to look at some examples together. So let me pull those up. So here it is. Okay, and this is assignment 8 for your notebook. Assignment 7 was your work from yesterday. So this is assignment number 8. And so let's just jump right in. All right, so let's look at number 1. There's my parallelogram. And right now, all I'm going to look at is the information that they are giving me right here. And I'm going to get that on my picture. Okay, now, unfortunately, when we hole punched it, it hole punched out the A on your picture. So right here, okay, that should say A. All right, so the first piece of information they tell me is that AB, segment AB, is equal to 10. So I'm going to come up here. I'm going to find segment AB, and that is 10. All right, without even looking at what they're asking me to find down there underneath, I'm going to fill in a couple other things. So AB is a side, okay, and what we just learned or what we need to know about a rhombus is that all your sides are congruent. It has 4 congruent sides. So that means if AB is 10, then we also know BC. BC would be 10. And that would mean CD would be 10 because CD is also a side. And it would mean DA or AD would also be 10. So I'm going to go ahead and put those on my picture just so I don't forget that fact. So now I'm going to look at the second piece of information they're giving me. So it says AC is equal to 12. So I'm going to come up here to my picture, find AC. There's AC. So this whole segment from A to C is 12. Now, what we know or what's new about the diagonals today is, sorry, it's not new. It's what we learned yesterday about the diagonals, that your diagonals bisect each other. So AC is a diagonal, so is BD. Okay, and when they intersect, they cut each other in half. So if the whole thing from A to C is 12, then to get the two smaller pieces, meaning to figure out what it is from A to E and what it is from E to C, then we're going to take 12 and divide it in half. So 12 divided by 2 tells me from A to E is 6 and from E to C is 6, because diagonals bisect each other. All right, let's look at the last piece of information they're giving me. The last piece of information they're giving me is BE is equal to 3. So I find BE, it's right here. I notice that BE is part of the diagonal. Okay, the diagonal is BD. And so this piece is 3. Okay, again, going back to that property that we learned yesterday about diagonals, diagonals bisect each other. So if that little piece from B to E is 3, then you know that this piece from E to D is 3. Okay, so now I've put everything on my picture that they've told me. And so let's drop down and see what they're actually asking me to find. All right, so they want segment BC. They're asking us for segment BC. So I go to my picture, I find segment BC. Segment BC is right here. Okay, it's a side, and since AB was 10, we know BC is 10. Next one, segment CD. I find segment CD on my picture. Oh, look, it's another side. All the sides are congruent, so CD is also going to be 10. Segment AD. Find AD on my picture. Again, it's another side, so it's also going to be 10. Segment AE. Now here's where you got to make sure, trace it with your pencil. So segment AE is from A to E. Okay, it's part of this big diagonal. It's half of it, and we said that was 6. And then the last thing they're asking us for is segment BD. Now be careful with this one. This one sometimes catches people. Segment BD is this whole diagonal. It's that whole piece. So we know from B to E is 3. We know from E to D is 3. So if we want the whole thing, we have to take the two smaller parts, add them together, and that would give me 6. So let's look at number 2. Number 2, again, don't try to answer the questions until you fill in your picture. Number 2, they're giving me an angle. The measure of angle TVR equals 30. That's the only piece of information that they're giving me. So I'm going to come to my picture. I'm going to find TVR. So again, trace it so you can see it. So it's this whole corner. This whole corner is 30. Okay. So just kind of look at your picture, be aware of what's happening. With that one angle, you should be able to find all the other angles in this picture, okay, with the properties that we learned. So let's drop down. Well, let's look and see what I mean real quick. I'm not going to look at what we need. Just watch this real quick. So if this corner, this angle is 30, then you know this angle is 30. Why? Because opposite angles of a parallelogram are congruent. So this whole corner is 30. If these corners are 30, then we have a way of finding angle R and angle T. Okay? Because remember yesterday we talked about these are consecutive interior, and consecutive angles are supplementary, so they have to add up to 180. So we would do 180 minus 30, and that would tell us what we have left for angle R, 150. If angle R is 150, then you know angle T is 150. So just with that 30 degrees, we could find the other three angles. Okay, we could also find these smaller pieces using one of our new properties. We could figure out what just this little piece is, what this little piece is, what this little piece is, but we're not going to do that right now because your picture starts getting a little crazy. So let's drop down and see what they want us to find, because we may not even need the numbers we just put up there, but let's look. All right, so they want angle RWS. Again, what some people struggle with is finding the right angle or the correct angle that they're looking for. So RWS, R down to W over to S, is this angle right here. So this is actually going to use one of our new properties that we did not have yesterday. Remember, diagonals bisect each other, but they are also perpendicular, meaning this diagonal, when it intersects this diagonal, makes right angles. So these four angles in the middle of your rhombus are all 90 degrees. So that one is 90, this one would be 90, this one would be 90, this one would be 90. But we're only looking for that one I actually have marked in green. Okay, and so since that's the angle I'm looking for and diagonals are perpendicular, that means it is 90 degrees. All right, so let's look at angle for TWV, the next angle. So again, I'm going to trace. So angle TWV, so here's T, go up to W, go over to V. I say, hey, it's another one of those angles on the inside. It's made by my diagonals. Diagonals are perpendicular, so this angle is 90. Let's look at the next one. They want the measure of VRW. Sorry, VWR, said that wrong. So again, trace VWR. And again, the biggest thing that we notice that if people have trouble, it's they're not tracing the angles. They're not finding or looking at the right part of their picture. And so then they're having a hard time figuring out the right answer. So trace it with your pencil. If you want a highlighter, we got them, just ask. V to W to R is that angle right there. So it's this piece right here that I'm marking with the arc. Again, it's made by the diagonals. They are perpendicular, so they make right angles. So that would be 90. All right, last one, angle RST. So again, gonna trace, see what we're looking at. So start at R, go down to S, come down to T. So the angle that they want is this angle. Okay, and we actually already wrote this on our picture. Okay, and we came up with 30. And we always are going to say why. Remember, it's opposite angle V. So this is not a new property. This is what we talked about yesterday. So opposite angles are congruent. So if this one is 30, then you know the opposite angle is 30. So see, we didn't even need the 150s. Okay, they didn't ask us for either one of those. So we did a little extra, but that's okay. All right, let's look at number 3. Again, I'm going to check out what they're telling me first. I'm not going to worry about what they're asking me. I'm going to put it on my picture before I try anything else. So angle ROP, start at R, go up to O, come down to P. So this whole piece is 50 degrees. Okay, and again, you should probably just get in the habit. If that angle is 50, then you know the angle opposite is 50. Okay, you could write 50 on this or just color code it. Okay, 50, they're green. All right, let's see what other angle they give us. Angle OPQ. Now be careful, make sure you're going O to P to Q. Some people are struggling mixing up our O's and Q's. So O, P, Q would be this angle right here. And they're telling me that's 130. So I'm going to put that like that. Again, probably a good idea to go, oh, this is opposite. Opposite angles are congruent. And put that on your picture. Some people also like to just go ahead and say, look, I have some diagonals that are intersecting there in the center. So I know these are all 90. So some people like to put the boxes in there. Go ahead if you would like to. I'm not sure if they're going to ask us that, but let's look. All right, so the first one says, find the measure of PQR. So again, let's trace, make sure we're looking at the right piece. So P to Q to R is this angle right here. Okay, we marked it green because it's opposite the 50. And so if it's opposite the 50 degrees, opposite angles are congruent, PQR is 50. And again, technically that's not new. That's what we worked on yesterday and then the day before, that Friday before we had the snow and the virtual days. All right, so now let's trace the other angle. QR, that should be O. There's no D on your picture. QRO. So start at Q, go up to R, stop at O. All right, so they're talking about this angle right here. Okay, we already marked it as 130 because it's opposite angle P. Opposite angles are congruent. So it just makes it a lot easier if your information's already on your picture, you've put on what you know using your properties, and then you're not trying to just guess or get stuck. All right, let's look at number 4. They only give me one piece of information for number 4. The measure of angle MPN is 20. So again, got to trace, figure out where I'm at. MP to N. Okay, so look, it's just this little piece, this little part of the angle, not the whole thing. Okay, if you look at what you trace, that's just that piece. So this is actually going to need you to fill in something using a new property. So remember, diagonals bisect your angles. So this diagonal right here cuts the entire angle, cuts angle P in half. Okay. And they've already told you what 1/2 is. They have told you that little angle that I have marked in magenta or red right there, they've told you it's 20. So this piece has to be 20. This little half has to be 20. Okay? Because that's what it means to be bisected. You get two smaller equal parts. So that piece of the angle is 20. This piece of the angle is 20. Okay? They didn't ask, but if they did say, hey, well, what's the whole angle? Well, then you would just say, oh, easy. That's 20 plus 20. So the whole entire thing altogether would be 40. Okay? I don't know if they're going to ask us that or not, but we're going to put it on there. Okay? And once you know that, then you can find angle M. You can find this piece. You can find angle N, this whole piece. And you can find angle O. But let's see what they're asking us. All right, so they went OMP. So I'm going to trace, see what I'm looking for. So O to M to P. All right, it's just this little piece here. Okay, there's a couple ways you can get here, but here's the fastest. Remember, it's a parallelogram. So that means this side is parallel to this side. If I'm looking for this angle, I can use this angle because this would be my transversal. Alternate interior angles are congruent. Now, some people are like, well, I didn't do it that way. I said this whole angle would be 40. So if that would make this whole angle over here, right here, 40. And then I did 40 divided by 2. That works also. All right, let's see what the next one they want. They want PMN. Okay, and my picture's starting to look a little crazy. So PMN is this other piece. Okay, again, a couple ways you could do this. Fastest way would be to recognize if the little piece below it is 20, the diagonals bisect or cut the angle in half, then the other little piece has to be 20. Again, not the only way you could get it. Okay, so if you have a different way and it is logically and mathematically sound, that's fine too. And then the last angle they want is the measure of angle OPN. Again, please trace. We have just found that people who don't trace their shape are looking at the wrong thing and getting the wrong answer. So O to P to N. Okay, so they want the whole angle. So we got to take this 20 and add it to this 20 because those are the two pieces that make up the whole angle. So 20 and 20, we already figured that out, is 40. All right, so I want you guys to try 5 and 6 yourself. Fill in your picture, mark what you know, and then come back and check with me. So Normally I would just pause and put a timer up, but what I want you to do right now is hit pause. Try to do 5 and 6. Once you try them out, just try it. Come back and check with me. All right, so hopefully you paused it. Hopefully you did 5 and 6 by yourself just to see if you could practice a little and kind of figure this out on your own. So let's check and see how you did. First thing you always do is put your information on your picture. So the only piece of information they give me for this one is that segment AD is 6. So I come up here, look at segment AD, put a 6. I recognize that it's a side. What do we know about sides of a rhombus? They're all equal. So that means this side is 6, this side is 6, and this side is also. And I can't write 6 apparently. Let's try that again. Okay. And they didn't, I don't know if they're going to ask me for those, but I just know that. So, you know, the more you can put on it, the less work you have to do when you get to the bottom. So that's all we know. We can't do anything else. We could put our right angles in here, right? Diagonals are perpendicular. So I could put my boxes in there just to remind me that those 4 angles on the inside are 90. So let's see what we got. All right, segment AB. Segment AB, oh look, it's a side. We already know that is 6. Segment BC, it's another side. All sides are congruent. Segment CD, another side. Okay, so we're looking up here. All our sides are the same measurement. Now they switch over to angles. All right, so I'm going to trace, make sure I'm looking at the right angle or the correct angle. So CED, C up to E, up now over to D is this angle right here. If you had already put your 90-degree boxes in there to remind yourself, then there's not a lot to think about. You're just going to write 90. Hopefully, if you did not put your boxes, you do remember new property. Diagonals are perpendicular, so that makes that angle 90. And the last one, the measure of angle AEB. Again, please trace A to E to B. Again, okay, it's an angle formed by our diagonals. We know that that's 90 because diagonals are perpendicular. All right, last one. Let's see how you did on 6. Let's take the 2 pieces of information they gave me, get them on my picture. So PO, so that's this whole diagonal, is 6. Okay. I don't know if I necessarily would write the 6 because sometimes what happens is people put it here, but they don't realize they want it to be the entire segment, and then they get confused. So what we recommend to people is if you know what the whole thing is, actually just figure out what the 2 smaller pieces are. So figure out what PA should be and OA. Diagonals bisect each other. So if the whole thing is 6, 6 divided by 2, that would tell me this is 3 and this is 3. That way, that makes more sense. When you look at that, you can go, oh, from A to O, it's 3. From A to P, it's 3. And you won't have the 6 kind of laying in a weird spot. Then they also tell me that QA is 2. So again, I'm going to trace it and see what I'm looking at. So Q to A, that's half of a diagonal. Okay. The other half is over here. Well, remember, in a rhombus, diagonals bisect each other. So if this piece is 2, this is the same. Because remember, bisects means cuts into 2 smaller equal parts. All right, so let's drop down and see what they actually want me to find. So they want OA. So again, make sure you're looking at OA. Okay, so we know that's 3. The entire diagonal is 6. Half of it, that half would be 6 divided by 2 or 3. Then they want AP. Okay, so they want the other half. And now they want QN. Okay, so be careful here. We do see people make a mistake here. QN is this whole diagonal. Okay, and if you look, we've broken it down into 2 smaller parts. This part over here is 2, and this part here is 2. So if we want the whole thing, we have to add our 2 parts to get the whole thing. So QN will be 4. So make sure you keep your chart next to you so you can refer to it. And make sure that you are putting all your information on your picture before you start trying to answer any questions. When you do get to the practice, if you have any questions, just let one of us know. Thank you.